Okay, so this is project number 1, and the title of this particular module is Constructive Line. And kind of part 1 is the planar shape, although part 1 is going to be a two-part focus. So module / assignment number 1. Now I want to be kind of clear about something, and that is everything that we do from this beginning point is going to advance us through the semester. So everything we do now is going to be leapfrogging into later, more complex projects. So it's very important, crucial that these beginning concepts be absorbed, applied, and then that critical thinking starts to come into view, and you start to make connections between how the ideas, the concepts, the techniques that we're using now are going to be applicable to no matter what you're drawing. In this particular drawing, we're going to be using planar shapes, but next cylinders, then compound cylinders, then we're going to get into increasingly more complex objects as the semester unfolds, all the way to the end where we start drawing organic shapes, skulls, flowers, even the human figure, although that will be a very brief part of the unit. But the same ideas that we use to understand planar shapes, the same techniques that we use to take them apart and to create a representation of them on this two-dimensional surface that is the drawing page. Same techniques there are the same techniques that you would use to draw a building, the Empire State, the Lincoln Memorial, you name the building, the same ideas are here. And that applies to mountains, boats, rivers, anything that you can think of. There's going to be an element of a planar quality, and this constructive line aspect is a very important aspect. The planar shape is one of 3 fundamental shapes. We won't get into all of them right now, but suffice it to say the planar shape is one of 3 shapes that really make up everything that you can imagine in the universe. So this is kind of a foundation of many, many other things. For instance, this page is a planar shape. My iPad is a planar shape. This desk is a planar shape. These clips have aspects of plane to them. So it's very important if we want to draw things, especially architectural geometric things, that we understand planar form. And the only way that we can understand it is by a kind of a deconstruction of it, which we then use to construct it into a whole. When we're doing constructive line drawing, we're kind of diagramming. Some people call it diagrammatic drawing. But what we're diagramming is relationships. So if I look at my fingers, you have the whole hand, but then you have constituent parts. And each one of these fingers has a relationship to the other. If I have my hand like this, there's a relationship between the finger and the thumb. If I do this, there's a different kind of relationship between the finger and the thumb. If I do this, there's a different angle here than if I do this. You have a compound angle. So these diagrammatic relationships are very important in understanding the parts to whole relationship. These are what we call spatial relationships. That's another term. So how do objects relate or how do parts relate in space to the whole shape, or how does one shape relate to another shape. So there's diagrammatic relationships in this hand, there's diagrammatic relationships in this hand, and then there's a diagrammatic relationship between the two hands. So we have to understand that. Now this all is dependent on something that we call point of view. Which I shorthand as POV. And point of view is also known as perspective. So perspective is our relationship to an object. So if I'm standing over here and looking at my fist versus standing over here and looking at my fist, there's going to be a different series of relationships, spatial relationships. So perspective is very important. If my hand is like this versus this, it's obvious that there's different relationships perspectively. Not so obvious if I move my hand from here to here. But believe it or not, even that small move changes all of the spatial relationships. Not dramatically, but it does change them. So we have to understand those changes in spatial relationships based on our perspective, our relationship to the object. And it's really important that we have a fixed perspective. That means that we want to make sure that when we're drawing something, we don't move side to side, we don't stand up and then sit down, we don't have an easel blocking our view of the still life so that we have to peek around it. Even moving 1 inch to the right or left is going to give you a completely different set of diagrammatic spatial relationships. And that's going to throw off your form, your shape. So diagrammatic relationships, spatial relationships, as found by the constructive line process, is really about creating a skeleton or a foundation of relationships. Now, I keep using this word relationship. Well, we talked a little bit about it, but let's talk about it in relationship to a box shape, because a box shape is this planar shape that we're looking for. So if we look at, say, this box, it's going to have a completely different set of spatial relationships. That's not a very good box. This box is going to have a very different set of spatial relationships than this box is going to have. Okay. Let's see if I can scroll down. This box is going to have a very different set of relationships because of its length to width to height ratios than, say, this box, which is going to have a very different set of relationships. When we're talking about these relationships, we're talking about the relationship between, say, the front vertical edge relative to the left vertical edge relative to the right vertical edge. If I'm standing looking at it from this direction, as I move my perspective and stand looking at it from this direction, it's going to give me a completely different set of spatial relationships, and I have to be able to constructively understand them, take them apart to find that foundation of relationships. So it's really about breaking things down to essentials. So even this box, if I was drawing it, I wouldn't be as concerned about this break between the top and the side as I would the overall shape. That's the most simple part about it. This comes later. If we go back to even a more complex box like this one, I'm not going to get, or this one, I'm having trouble with my computer because I don't know what I'm doing. So if I look at this box, let's go ahead to photos. If I look at this box, you know, the fact that it has 4 slats, the fact that it has this wood grain, that it has these little connecting hardware pieces, that's irrelevant. That doesn't matter. That's not essential. These are particular details. I want to understand the essentials of that box first before I get into these. Because if I don't have those right, then the size and relationships of these parts to the whole, the proportion of these relative to this is going to be off. So you have to start with a simplification. It's all about simplifying. It's a constructive line drawing is a technique. I'm not asking you to do anything more than use this technique. It's also a process. So there's a step 1, a step 2, a step 3, a step 4. And in general, it's all about working from simple to complex, from general to particular, from what I call primary to secondary, to tertiary, details. It's about a kind of scientific methodology where you know nothing and you start off with a rough researching estimate. And then over time you observe more, you learn more, and you start to refine your understanding. And then you learn more and you learn more until you come to a conclusion or a finish. And just to let you know, this technique, this process, it's also about leaving the looking, meaning leaving your calculations, leaving marks that express these spatial relationships. It's not about erasing and cleaning up your calculations, showing your work, like they say in math. And in addition to leaving the looking, there's this kind of movement from light to dark in the pencil pressure. And I want to say, especially in this constructive line process, no erasers. Do you hear me? No erasers. No erasers. It's about leaving your looking. Our first unit, our first fundamental type of shape, is really the same principles that we're going to be applying to all shapes that we draw. And that is, we're looking for the 3 fundamental, not shapes, formal elements. And when we think of elements in science, we think of, what's the simplest constituent parts of a shape or an object or a chemical combination. That should be elements. I'm a really bad speller. All right, so let's think about the three fundamental formal elements. They are point, line, and shape. And we're dealing with planar shapes. In fact, sometimes people say point, line, and plane, but not all shapes are planes, really. For instance, you have cylinders and spheres, which aren't really planes, or you could think of them as a warped plane, but it's better, in my opinion, to describe them as shapes, and you have different shape types. And by the way, cylindrical, spherical, planar, those are the three fundamental shapes. But those shapes all have constituent elements called the three fundamental formal elements of point, line, and shape. Point is the most basic. It's a dot. It could be small or bigger, but it defines a point in space. And your picture plane, this is a plane itself, just like this iPad, just like this phone that's recording, just like this desk that everything is on. These are all planes. If I relate 2 points together, all of a sudden our eye starts to see that relationship as reminding us of something else. What would that be? Think about it. Well, it reminds us of a linear relationship, right? They're across from one another. How are they across from one another? They're across from one another horizontally. Relationship. What about if I have a point here and a point here? What sort of relationship is that? That's a vertical relationship. And our eye assumes that. I mean, if I do this, we don't think of this. We think of the simplest solution, the simplest relationship, or the most direct route between any 2 points is a straight line. That's the fastest way to get there. So we think of this as being a vertical line. Now, what's the relationship here? If this is horizontal, and by the way, horizontal relative to the picture plane, vertical relative to the picture plane, what's this? It's diagonally, right? Diagonal relationship, right? So these points and their relationship, remember we use that word, how they relate to one another, describes a certain kind of relationship. And in actuality, what that relationship is a line, right? This is an implied line. Our eye fills in those gaps. But if we connect the dots, which we all did when we were little kids, we get a line. And when we have points that are relating to one another that we connect with lines, we enclose space, separating it from the ground around it. So we get a figure or a shape against the ground of our page, right? So if I create points like this, we get a square figure against the ground. If I create points like this, what sort of shape do we see? Well, we get a circular shape, a circular figure against the ground. If I connect shapes like this, or relate points like this and connect them with lines, points connected with lines, create a shape that's like a trapezoidal shape, okay? So these relationships of point, line, and shape are what we're looking for when we're dealing with a box. And these all depend on our point of view. Okay, that's really important. So let's think about this. For instance, if I have a box here, like so, we're not seeing it from a frontal point of view. We're seeing it kind of moving back in space, moving away from us, right? We're seeing it from a 3/4 point of view, okay? Versus the same box seen from a frontal point of view. Versus the same box seen from the opposite 3/4 point of view, right? So now we're seeing more of this side, right? Versus the same box seen from a profile point of view. So depending on which way we're looking at these, depending on our perspective, the relationships of points are going to change. Like for instance here, the relationships in this profile point of view are horizontal. Here, as we move that box in space away from us, they become diagonal. They don't change other than how we're perceiving them. And one of the biggest problems people have is they tend to think of things from a static point of view. Okay, so if I'm drawing a table, you know, we think of the tabletop as being a rectangle, and then we have the legs of the table, right? But that doesn't look like a table as we see it. It looks like a table as we think it. If we were to draw that table as we see it, we would see perspective starting to happen. Right? So that top would, what we call, lay down in space instead of flipping up. And that's because these relationships, vertical, became diagonal. So diagonality tends to create space, all right? You know, a really extreme version of this would be a really long and tall skinny box. So let's say that I have a really long and tall skinny box. So the top of it is above our head. So you'll notice that we don't see the top plane at all. If we were to, you know, climb up on a ladder and look down, we might see the top. So our point of view has changed. Here we're looking up, here we're looking down at the box. If this box was to lay down in space, we know that it's very long, so its height versus its width. Versus its depth. We understand those relationships, we kind of conceptualize them. But if I lay it down in space, all of a sudden something that's long and tall is going to appear very short, even though we understand that it's a long box because of those extreme angles that we're seeing. Does that make sense? And if we were to tip it up on its side, we would see more of that, but it still wouldn't look the same height and width that we're seeing when we see it kind of from a 3/4 view. Another way to think about it is if we were to look at it from a frontal point of view, and I'll draw a smaller scale, all we would see is the front plane and the top plane. We wouldn't see the front plane, the side plane, and the top plane. So as we move in space relative to those objects are really going to change in the way that we comprehend and understand them. You'll notice here I've written three things: height, width, and depth. This is a two-dimensional surface. So when we're drawing, it's two-dimensional. But we're giving it the appearance of 3D. And it gives us a dimensional illusion, a three-dimensional illusion. So for instance, if I just draw the front plane of something, all we're seeing is height and width. It's very flat. And by the way, if I was to look at this box with my eye level, seeing neither the top, the bottom, nor the sides, it would become a flat plane. But the minute that we change our relationship and we start to see the depth of the object, we start to get this three-dimensional illusion happening. Does that make sense? So again, you know, if I've just got the top line that's horizontal and the side line that's vertical, I'm seeing a two-dimensional shape. The minute that I add those diagonals and a top plane, or another iteration would be seeing the side plane and the top plane, we get three dimensions. We get height, we get width, and we get depth. Okay? So what we're doing is we're measuring relationships. So how do we do that when we're drawing? Well, that's what we're going to talk about in the demonstration video. Okay, so I start out with a vertically oriented format. This is my 18 by 24 inch newsprint. If I turned it on its side, it would be a horizontally oriented format. So vertical, horizontal, diagonal, that's called format. Now I'm taking my HB or a 2H pencil, which is very hard, lots of clay, and you'll notice that it draws very deeply or lightly. So the first thing I do is I look for something simple, like these vertical edges. I could start with the left, the right, top, bottom. Diagonals are not as easy, so I like to start with the vertical. Now you'll notice that I put that line to the right of the page. The reason that I put it to the right of the page is because there's more on the left side of that line than there is on the right. And I want this box to be as big on the page as I can without going off the page. The next thing I do is I measure the angle using my pencil, and I try to translate that angle to my page. You can notice that I'm keeping my pressure very light. You might barely be able to see things. Doing the other vertical. Now the thing is I don't know how tall it is. So I have to figure out how tall it is. Checking my angle, looks good. Checking my angle, looks good. Checking my angle, looks good. Now I'm looking at the bottom angle. Still haven't determined the height of the box. The side angle on the top. Bottom. And you'll notice, again, I'm keeping it very light. Now I'm going to figure out the top, and here I'm using what's known as triangulation. So I know 2 points, the front corner on the bottom and the side corner on the bottom. So I draw a little angle, make a mark with my pencil, check that angle, make sure that it matches, and then I can continue it on. And where it crosses my vertical, right there, that point is where the top of my box is going to be. That's the height of that vertical line. And I can just simply find that angle, which is very close to horizontal, just a little bit above. And I can draw it in. I know it's hard to see, guys, but that's purposeful. Because you're going to make corrections. For instance, I noticed the left vertical edge of the side of the box is leaning. That's going to have to be corrected. Now the angle of the left side, the directional relationship. Incidentally, that line that's implied between the left corner and the right top corner is called a diagrammatic or constructive line. Thus the name of the project. You can see I'm getting my pressure a little bit more dark so that I can see, checking it, rechecking it, checking it again. Now I got to figure out that back edge. How do I know where it is? How do I know where the back edge of the right side is? The top. Well, I can look for the angle between the bottom left corner and the top right corner. Very shallow, very steep angle. So I lay in a little line, make a mark, and then just continue until I cross that top diagonal. Now I know this is a vertical line, so I can just drop it down. And you can notice I'm getting a little bit bolder because I'm becoming more confident with the shape that I'm winding up with, proportionately speaking. Notice I'm using my whole arm. I'm not making little sketchy marks, not little itchy marks. I'm using very fluid marks. I'm actually drawing from my shoulder. And that's going to give you a straighter, more fluid line than if you use your wrist. That's why we're standing at an easel instead of laying it on a table. Now that back edge. If I've got the back corner of that right side correct, then all I should have to do is find the angle, and I should have the right proportion of the top size-wise. Now I'm going to come in with my 4B pencil, and I'm going to give it a lot more pressure. So I'm literally leaning in more with a 4B, which has less graphite, which makes it oilier, which makes it darker. Notice how I straightened the line of that left edge so that it was more vertical with the side of the page. I'm not happy with placement. I wish it was a little further to the right. But that's something that comes with practice. You can see the end of this diagrammatic stage is about refining by darkening. But I'm leaving the diagrammatic relationships. I'm leaving those angles visible. This is not meant to be gotten rid of. In fact, you might want to reinforce them so that I can see that you used them and use them to check. Chances are there's things that you need to tweak. So, left front corner to back right corner. There's a triangulation there. And it looks good. So I'm going to start with the edge closest to me, the vertical, put it relatively in the center of the page, because it looks like the left and the right halves are equal in size. That's a guesstimation, meaning the distance from the center line to the right edge and the distance from the center line to the left edge is approximately the same. So it should go in the middle of the page. When I make that vertical line, I have no idea how tall I'm making the box. I'm just guesstimating. We want it to fit on the page without going off. Again, that's called a closed composition. But we want it to be as large in scale as we possibly can make it. Just kind of observing, looking at my drawing, stepping back. Now I got to find how tall it is. So I drop in my triangulation mark, measure it, make a mark, measure it, make a mark, and draw that mark from the corner to the top. That determines, put a little point there, exactly how high the box is relative to the width. As long as we're on the page, the width is good. We can heighten it if we need to. Width is usually more important than height when it comes to scale. Not crucial, but a little more important. So again, I'm finding these angular relationships. I know they just tangent off of my vertical line height. Everything is relative to that vertical line height, both the right and the left sides, and those angles that show the depth. Drawing a little bit darker. There's the bottom edge, and I'm going to triangulate from there to the top right edge of the box, the top right corner of the box on the right side. So again, I triangulate. I'm drawing those red marks just to show you what I'm looking for. In practical circumstances, when you're looking at a box, you don't walk up there and draw a red line on it. I'm illustrating. So I, using my whole arm, draw an angle. See where it crosses my diagonal. See if that looks okay. Now to me that looks a little short. In the picture, the right side actually looks a little bigger. So that must mean my line is wrong. So here I am comparing the left and the right sides using my fingers. And I see that my left side is actually a little shorter. Inside of my finger to inside of my finger. And I move my index finger over, and I can see that the pinky's a little bit farther. I can also use my pencil and compare. And translate it over. They're at least close to equal, so I need to move that line out. And that's okay. That line of verticality that was the wrong edge, that just becomes part of your calculations. It's not something that you need to worry about. And then we can draw in that diagrammatic implied angle between the two corners and see if it matches. Back left edge, drawing the angle, and we know where the corner is on the right back edge of the front plane, so it's just going to be a matter of determining the angle. Now you can find the corner, front corner to back corner relationship, and that'll give you something to shoot for as far as the angle of that back right side is concerned. So I draw a line. Looks like it's just a little bit right of vertical. So I make a mark, draw that diagrammatic constructive line, and shoot for that mark. Now I've got a kind of ghost constructive line drawing here. Now I'm going to take my 4B pencil, again the softer pencil, and I like to start with the corners and just push hard. And then the next corner. And let the eye kind of fill in the gap. You don't trace around it like you're doing a coloring book. You just create these fluid lines, starting from corner, working towards the center. And you can see how I'm getting some nice straight lines. It's darker, it's more refined. The diagrammatic lines start to disappear. You can see that I'm changing my relationship to the page. I'm drawing on the right side, I move to the right side. When I'm drawing on the left side, I move to the left side. You can see how that really starts to polish up and refine things.